Welcome to Mastering Area. Today we'll go from basics all the way to Olympiad level. Let's start with basic concepts. A rectangle has a width and a height. Its area equals width times height. Next, the square. All sides are equal, so the area is simply side squared. And finally, the circle. Its area equals pi times the radius squared. Many area formulas can be traced back to fundamental concepts. Let's derive the formula for the area of a trapezoid. The trick is to divide and conquer, splitting it into two triangles. Triangle A1 has base B and height h. Triangle A2 has base A and the same height. Adding them together, we get the trapezoid formula. A circular sector is like a slice of pizza. It has a radius r and an angle theta. The sector is a fraction of the whole circle. That fraction is theta over 360 degrees. So the area is theta over 360 times pi r squared. Now let's practice with some area problems. Two squares of side 10 and 6 are placed side by side. Connect the top left of the large square to the bottom right of the small square. Can you find the triangle's area? Here we have two squares side by side. A large square with side 10 and a small square with side 6. Draw a line from the top left corner to the bottom right corner. This creates a big triangle. The base of the triangle is 10 plus 6 equals 16, and the height is 10. Applying the triangle area formula, the area is 1/2 times 16 times 10, we have the answer 80. Now let's try another one. A square has side 10. Two quarter circles are drawn inside from opposite corners. Can you find the area of the shaded leaf region? Observe carefully. Do you find that the leaf shape is the overlap of two quarter circles drawn from opposite corners? So the leaf area equals the two quarter circles, minus the full square. Each quarter circle has area 1/4 pi times 10 squared, which is 25 pi. The square's area is 100. So the leaf equals 25 pi plus 25 pi minus 100, which is 50 pi minus 100, approximately 57. Now for the real challenge. Can you solve these past Olympiad questions? In this question, we have a large circle with diameter 21 centimeters. Inside it are smaller circles that touch each other. We need to find the unshaded area. Before we calculate anything, let's think about this step by step. First, how many different circles do we see? We can see three types of circles here, one large, one middle, and three small ones. Now, the large circle has a diameter of 21 centimeters. Look at the diagram carefully. Three small diameters fit exactly across the large one, so each small circle has a diameter of 7. So the small circles have diameter 7, and the middle circle spans two small diameters, giving it a diameter of 14. We now know all three sizes. Now here's the key question. How do we find the unshaded, or white, area? Let's think about what's white and what's grey. Start with the large circle. Subtracting the middle one also removes the two white circles inside it. By adding one small area back, we find the total unshaded region. We have know the size of each circle type. Now we can calculate the area of each. Finally, applying our formula, large minus middle plus small, we get an unshaded area of 231 square centimeters. Did you solve it? Let's move on to the next challenge. In this problem, we need to find the area of the quadrilateral EFGH inside rectangle ABCD. Let's look at the geometry carefully. The area of EFGH can be found by taking the large triangle BEC and subtracting the triangles below it. Our strategy is simple. BEC minus BGC, minus the bridge triangles FBG and CHG. Step 1. The rectangle's total area is 3 times 7, which is 21. Triangle BEC is half the rectangle, so that's 10.5. Triangle BGC is a quarter, giving 5.25. And we're told the two wing triangles sum to 7. Now we find the bridge triangles FBG and CHG. Since the bowtie triangles sum to 10.5, and the outer wings given us 7, the bridge area is 3.5. Subtracting everything from triangle BEC, we find the final area is 1.75. Nicely done. Ready for the next one? 5 circles, each with radius 7, form a star pattern. We need to find the total shaded area inside the circles. Let's label all 7 angles formed by the star. Notice how these angles relate to each other through the triangles. First, using triangle angle sums, we find that angle 1 plus angle 2 equals angle 3 plus angle 4. Similarly, angle 6 plus angle 7 equals angle 3 plus angle 5. Now we add up all the shaded angles. By substituting our equalities and simplifying, we see that the total shaded angle is 540 degrees. With a total shaded angle of 540 degrees, the area is 540 over 360 times pi r squared. That gives us a final answer of 231 square centimeters. Let's recap what we learned today. First, familiarize with the basic area formulas. Second, break complex shapes into simpler ones. Third, use the overlap principle. And fourth, move shapes to form known ones. Keep practicing, and see you in the next video.